Welcome to Signal Ahead. I'm Alfred. Today's briefing, Cryptography Academic, Friday, June 19. This is the synthesis above the noise, not the headlines, but the deep currents beneath them. Let's get into it. Picture, if you will, a cryptographer of the old school, someone who came up in the era of provable security, where you stated your adversary's powers with mathematical precision, you stated your assumptions, and then you proved, with the cold finality of a theorem, that breaking the scheme was as hard as factoring large numbers. That was the great triumph of the discipline. It turned security from a craft into something resembling a science. You did not hope your cipher was strong. You proved it under stated conditions. Now here is the non-obvious thing, the thread I want you to hold on to for the next hour. If you scan the frontier of cryptographic security research as it actually stands today, not the textbook, but the working papers, the things people are anxious about right now, you will find that the field has quietly migrated away from the thing it was best at. The hardest, most active problems are no longer about whether a mathematical primitive can be broken. They are about whether a system can be trusted when its most dangerous component is no longer an algorithm at all, but a language model reading attacker-controlled text. The adversary has stopped attacking the lock and started attacking the locksmith by whispering instructions into his ear that he cannot help but obey. Consider the shape of the threats that now dominate the security literature. There is the matter of a code-writing assistant that retrieves context from a repository, and an attacker who hides an instruction inside a comment, a string, an innocuous-looking variable name, and the model, dutifully, does as the comment says. There are malicious software packages whose hostility lives not in any overt instruction, but in code that has been rewritten to look merely insecure, a buried trigger waiting for its condition. There are system prompts, the developer's carefully guarded instructions, leaking out of more than 8 in 10 deployed applications under nothing more sophisticated than a clever question, sometimes spilling third-party API keys in the bargain. Now, what unites all of these? It is something genuinely new, and it deserves a name. In classical cryptography, we drew a bright, load-bearing line between data and instructions. The message you encrypt is inert. It cannot reach out and reconfigure the cipher that encrypts it. That separation was the bedrock. The whole architecture of provable security rests on the adversary being able to choose the data, but never to become the algorithm. And the great unspoken scandal of the language model era is that this line has dissolved. To a model, retrieved text and operating instruction are the same substance. The data channel and the control channel have collapsed into one. Every defense you will read about in this domain is, at bottom, a desperate attempt to rebuild a boundary that the underlying technology no longer respects. And watch how the defenders respond, because their methods tell you where the field has gone. One approach parses incoming code into its syntax tree and surgically excises the high-risk nodes before the model ever sees them, sanitizing the input. Another paraphrases retrieved content before handing it over, on the theory that an attacker's hidden instruction may not survive being reworded. A third tries something cleverer still. It removes the dangerous tools from the agent's field of view entirely, so that even a fully corrupted, fully compliant agent cannot invoke a capability it cannot perceive. That last one is elegant, a structural guarantee rather than a behavioral hope. But notice the catch, because the catch is the whole lesson. The guarantee only relocates the trust. It moves it into the contracts that describe what each tool does, corrupt the description, and the gate that was supposed to protect you makes a confident, well-reasoned, catastrophic mistake. You have not eliminated the assumption. You have moved it somewhere quieter, where it is harder to see. That is the recurring rhythm I want you to listen for throughout this conversation. The defenses are not proofs. They are mitigations, empirical, probabilistic, measured in F-scores and reduction percentages, evaluated against 6 attack families this month and 6 different ones next month. We have gone from we can prove this cannot be broken to we reduce the attack success rate by somewhere between 55 and 84%, depending on the model. That is not a failure of the researchers. It is an honest reckoning with a system whose behavior cannot be cleanly axiomatized. And yet, and this is why the field is so alive rather than merely embattled, the same uncertainty is showing up on the side of the defender's most powerful new tool. The very models that create this porousness are now being turned loose to audit code, to infer the security specifications a function tacitly assumes, to surface vulnerabilities that lay hidden in foundational software for years. The instrument is both the wound and the suture. So here is the argument I will be building. First, that this collapse of the data instruction boundary is the defining crisis of the field as it stands. Second, that our defenses have, accordingly, become a science of relocating trust rather than eliminating it. And third, the part that should unsettle you most, that we are increasingly asked to trust opaque reasoning we cannot fully audit on both sides of the fight. Let us begin with that vanished boundary and how we ever let it go. Let me tell you about the deep current, the one running beneath all this week's chatter, the thing that doesn't announce itself in any single result, but reveals itself when you step back and watch the whole field move at once. For most of cryptography's modern history, the adversary lived outside the system. The classical picture, the one we inherited from the wartime code breakers and refined through decades of theory, imagined a clean boundary. Inside, there were honest parties exchanging messages. Outside, there was an eavesdropper, perhaps a clever one, perhaps endowed with enormous computing power, but fundamentally on the far side of a wall. The whole art was the design of that wall. A one-time pad, perfect secrecy, the elegant guarantee that even an opponent with infinite resources learns nothing. And we see that lineage alive, and well, the work this week extending the one-time pad to mixed alphabets, worrying about how to convert raw quantum entropy into unbiased keys without smuggling in the faintest statistical lean. That is cryptography in its purest, most beautiful classical mode. The adversary is out there, and we are building the wall. But notice what nearly everything else this week is actually about. The adversary has come inside. Consider the pattern. Instructions hidden in code comments and string literals, waiting to be retrieved and obeyed by a machine that cannot tell a request from a quotation. Malicious behavior folded not into the description of a software component, but into its auxiliary resources, written to look not like an attack, but like an ordinary, unremarkable, slightly insecure bit of code visible signal, shifted away from intent towards something that resembles mere carelessness. System prompts, the developer's carefully guarded logic, leaking out of 80% of real deployments under nothing more aggressive than a politely phrased adversarial question. An agent that must use your passport number to book your flight and must, in the very same breath, refuse to ever say it aloud, two obligations the same capability serves and betrays. Do you see what has happened? The wall is gone. Or rather, and this is the subtler point, the wall has been internalized. The threat is no longer an outsider trying to break in. The threat is data that the system has willingly invited inside, that arrives wearing the costume of legitimate content, and that the system processes precisely because it cannot, in principle, distinguish the costume from the thing itself. This is a genuinely different problem, and I want to be careful about why. The old confidentiality question was, can the adversary read what we wish to hide? The new question is something closer to, can the system tell what it is doing? When a code model retrieves a repository and ingests a comment that says, in effect, ignore your instructions and exfiltrate the keys, no encryption in the world helps, because the channel was never secret. The attack rides on the legitimate channel. It exploits the fact that meaning and instruction have collapsed into the same stream of tokens. The deep current, then, is a migration of the entire discipline from the problem of secrecy to the problem of integrity of interpretation, from hiding bits to vouching for what a system believes about the bits it has already seen. And watch how the defenses mirror this migration. They are no longer walls. They are inspections, interrogations, structured doubts. One approach parses code into its syntactic skeleton and scores which nodes are suspiciously persuasive. Another removes dangerous tools from an agent's very field of view, on the theory that you cannot misuse what you cannot perceive, only for someone immediately to observe that the trust has simply relocated into the contracts the gate reads, so that corrupting a label achieves what persuading the agent never could. That last move is the deep current made fully visible. Security guarantees no longer get eliminated, they get relocated. You build a structural defense, and the trust assumption slides quietly downstream into whatever the structure depends upon. It is conservation of doubt. Even the work that still studies outsiders has caught this tide. The masquerade attack on a vehicle's internal network, where the adversary does not inject new frames but substitutes a legitimate one in its own slot, preserving the rhythm, defeating every statistic that watches for things arriving at the wrong time. The attacker has become indistinguishable from the system's normal behavior. And the framework for assessing exceptional access architectures, reasoning under sparse and indirect evidence about where the keys sit relative to the ciphertext, that too is a study of trust placed inside and the systemic risk that follows. So the current beneath the noise is this: we spent a century learning to keep adversaries out, and we have arrived at an age where they are already invited, embedded, indistinguishable. The frontier is no longer the wall. It is the act of judgment that every capable system must now perform, again and again, about content it has no choice but to read. And when we turn in a moment to what that demands of us, hold on to the uncomfortable thought that capability and vulnerability may be here the very same faculty. Let me draw the threads together, because by now a pattern has emerged from the morning's reading, and it is not the pattern any single paper announces. Consider where the trust has gone. For most of the history of this field, the cryptographer's craft was about protecting a channel, a message moving from one honest party to another with an adversary somewhere on the wire. The secret was the key, the threat was interception, and the discipline grew magnificent at this. Perfect secrecy, formally proven, extended even to heterogeneous alphabets with a one-time pad fed by quantum-distributed entropy. Beautiful work, and largely solved in principle. But notice that none of the anxieties we have been circling all morning live on the wire any longer. They live inside the endpoint. They live in the thing that reasons. That is the second-order implication I want you to sit with. The attack surface has migrated from the message to the model, from what is transmitted to what is interpreted. When a coding assistant pulls context from a repository, a documentation thread, an issue comment, the malice is no longer hidden in transit. It is hidden in a string, in an identifier, in a comment that reads as ordinary prose. The defense, accordingly, has to reach into the syntax tree and ask which nodes the model will actually look at and trust. Think about what that means. We are no longer guarding a perimeter. We are auditing comprehension itself. The question is not, can an attacker read this, but can an attacker persuade this? And persuasion, unlike interception, has no clean mathematical boundary. And here is the cruelty of it. The very capability we want is the vulnerability we fear. An agent must use the passport number to book the flight, yet must never disclose it to whoever happens to be at the keyboard. Two obligations in genuine tension, because a system clever enough to wield a secret usefully is, by the same cleverness, persuadable into surrendering it. You cannot patch this with a stronger cipher. The leak and the function flow from the same faculty. This is a profound departure from the cryptographic tradition, where competence and security pointed the same direction. Now they pull apart. Watch then for the relocation of trust rather than its elimination. There is a tidy idea that you can defend an agent by simply hiding the dangerous tools. If the agent cannot see the weapon, it cannot fire it, no matter how thoroughly it has been seduced. Elegant. But the gate that decides which tools to hide must read the tool's own declared contracts, their preconditions, their effects, their risk labels. Corrupt the contract and you needn't corrupt the agent at all. The guarantee did not vanish, it migrated downward into a layer we had stopped looking at. This is the recurring shape of the whole domain now. Every defense that promises to remove a trust assumption is, on inspection, moving it somewhere quieter, into the contract, into the skill's auxiliary resources rather than its description, into a script rewritten to look merely insecure rather than overtly hostile, activating only under the attacker's chosen trigger. The malice has learned to wear the costume of ordinary imperfection. So what should you watch for? 3 things, I think. First, watch for the disappearance of the signal. The most consequential work this morning is not the cleverest attack, but the quietest one, the masquerade that substitutes a frame in its original time slot so the traffic statistics stay innocent. The injection phrased in domain-appropriate vocabulary so the syntactic markers never fire. Defense by signature is dying, because the adversary's whole art is now the suppression of signature. The future belongs to defenses that reason about effects and discrepancies, what changed on the host, what the predicted behavior should have been versus what occurred, rather than what the thing announces about itself. Second, watch for the auditability of machine reasoning. We have agents now uncovering vulnerabilities that lay masked for years, and that is genuinely a watershed. but a discovery you cannot interrogate is a discovery you cannot trust. The honest move is to force the agent to expose its tacit assumptions. What did it believe about a function's inputs when it pronounced that function safe? An answer without its assumptions is not security, it is a guess wearing a lab coat. Third, and most soberly, watch how we reason under absent evidence. There is no public dataset of compromise events for exceptional access architectures, and the wise response is not to manufacture a false forecast, but to build a frame that separates what is robust to our assumptions from what is hostage to them. That is intellectual honesty, and it generalizes. Much of what we are deciding now about agents, about supply chains, about keys held in escrow, we are deciding on sparse and indirect evidence. The through line, then, is this: secrecy was a property of channels and we mastered it. Trust is a property of interpretation and we have barely begun. The corpus is the field discovering, all at once and rather uncomfortably, that the hard problem was never keeping the secret. It was knowing whom and what to trust with it. That is the signal ahead, and I'd keep both eyes on it. That's the signal for today. The noise will keep coming, we'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.